This is for Module 9 practice test. If you have any questions, let me know. We look at number 1. It says use the square root property to solve the equation. So just remember, if you have a square, you can find the answer by using the square root property, which means we're going to square root both sides. Just remember that when you square root the other side, that you're going to plus or minus whatever is there. So that's what I did. I found the square root of x minus 4 squared, which is just x minus 4, and then the square root of 25 can be plus or minus 5. If I take my 4 to the other side, if it's a positive 5, my answer is 9. If it's a negative 5, my answer is negative 1. Alright, number 2, I brought my 4 to the other side, which made it a negative. I took the square root property of each side. So when I find the square root of 25x squared, I'm left with 5x. And when I take the square root of the other side, I have a plus or minus the square root of negative 4. So I went here and kind of showed you, remember, if you have a negative in a square root, you can divide that up into a 4 and a negative 1, and your negative 1 becomes an I. Now you can put your I on the outside, on either side. I've seen it done both ways. I have a tendency to always put it on my left side, or I mean my right side, sorry. Then I can find the square root of 4, which is 2, and it's going to either be a positive 2i or a negative 2i. So I have my two equations here. If it's a negative 2i, then my answer is negative 2/5 I. If it's a positive 2i, then my negative is 2/5 I. So they kind of write it like this. Either way will work. Alright, number 3 says complete the square. So just remember your b term, you're going to half it and then square it. So when I halved it, I got negative 4, and then I squared it, I got 16. Now I kind of did it the long way just to kind of show you, but you can go straight from finding this to this right here if you want to, but I got 16, so I add 16 to both sides. Then I factored this, which should always come out to a perfect square, and then I squared both sides. And then this side would turn to x minus 4. This side can be a plus or minus 31. When I take my 4 to the other side, it's a positive 4, so our final answer is 4 plus the square of 31, square root. Alright, number 4, find the distance between the pair of points, give an exact answer. So remember, the distance formula is x squared, second x, take away the first x, and then we want to square that, and then we do the second y and the first y, and then subtract those and then square, and then add those two together. So first we just want to kind of define, what they are. And if you do the opposite, you call this x2 and x1, just make sure that this is the 2 and this is the 1. Alright, so we're going to plug them in the formula. X2, so 3 take away 0 is 3, and then square it, that's 9. Our y2 is 9, 9 take away 0 is 9, and then square it, that's 81. So we now have a 89. And we can make that prettier. I'm sorry, I can't even add today. That's a 90. 81 plus 9 is 90. And then we can make that prettier. Let's see, I could break it down into 9 and 10. Then we could find the square of 9, which is 3. But the square root of 10 is still 10. So our final answer is 3 radical 10, square root of 10. And we just say units because we really don't know, what they are. Alright, number 5, using the same formula. So this is x1, y1, x2, y2. So we're doing, and this one we'll have to write out a little bit more. Alright, so x2 take away x1 squared plus y2 take away y1 squared. And then let's simplify this more. So this one would be just radical 17 squared, which is just 17. And 9 minus 1 is 8. 8 squared is 64. Add those two together. And we get 81. So now we have radical 81, or the square root of 81. So our answer is 9 units. Alright, number 6 says find the midpoint of the line segment with the given endpoints. So don't forget that formula. And it doesn't really matter which you call 1 or 2, just be consistent. That's our formula. So I'm just going to say this is x1, y1, x2, y2. So if I plug these in, I have 9 take away 6 divided by 2. And let's see, which one did I do first? And 0 take away 6 divided by 2. So we have 9 minus 6 is 3, so 3 over 2 for our x. And then negative 6 over 2, so negative 3 for our y. Alright, let me get some paper for number 7. It says use the quadratic formula to solve the equation. So need to know the formula first. So it's minus b plus or minus b squared minus 4ac over 2a. In this case, our a is 1, our b is negative 7, and our c is negative 9. So we're just going to plug these in here. So negative b would be 7 plus or minus b squared is 49 minus, and then we'll do 4 times a times c all over 2a's. And let's simplify this. So this is negative 36, so now we have 49 plus 36 because of two negatives, still over 2. And then we do 49 plus 36 and we get 85, still over 2. Oops, sorry, this is square. And this can't be broken down anymore, so this is our final answer. If this was a number that, you know, was an even number, you probably could have broken it down a little bit more, but since it's not, we're done. Alright, number 8. Our A is 4, our B is 12, our C is 4. So, sorry. Negative b plus or minus b squared minus 4ac all over 2a. So 2 times a is 8. Simplify this. So 4 times 4 times 4 is 64. If we simplify this more, 144 take away 64, that's 80, still over 8. And then this one can be broken down a little bit more. So 80, we can do 4 and 20, which also is 4 times 4 times 5. So that's what I'm going to start with. 4 times 4 times 5 all over 8. So the square root of 4 is 2. So if we put 2 out there, and this 2, so now we have 4. This guy stays a 5, and then this is an 8. Now we can simplify this even better, so kind of let me put this up here first. So that's our almost answer. But if we put this over this and this over this, we can divide 4 out of both of those. So that would be 3 over 2. And then our second half, we can take 4 out of both of those. So that just leaves radical 5. And we have 2 left on the bottom. So you can write it 2 different ways. Either one of these ways will work, or either one of these ways is correct. Alright, number 9. Alright, use the discriminant to determine the number of types of solutions to each equation. Alright, so remember the discriminant is just that inside of that quadratic formula. So A in this case is 1, B is -8, and C is 16. And depending on what we get, depends on what kind of answer we have. So if I do the problem, B squared is 64. And then 4 times A, which is 1, times C. So we get 64 minus 64, so we get 0. So when we get 0, there is only one real rational answer. So the answer is D. So when the D equals 0, this is what happens. Alright, number 10. Our A is 1, our B is -3, our C is 6. So B squared is 9. Take away 4, A is 1 and 6, so we have 9 minus 24. So that gives us a negative, oh my gosh, my brain is not working today. So this is where our discriminant is less than 0. So when that happens, then we have 2 imaginary, oh, I had it covered, 2 imaginary solutions. So that's when D is less than 0. So we got -15. So our answer is E. I'm like, I didn't see the answer, or I had it covered up. Alright, number 11. Solve the equation by the method of your choice. Simplify solutions if possible. Alright, so if I look at number 1, first thing that pops in my head is the square root property. So I'm going to square this, plus or minus. This takes it out. Square root of 81 is 9. 2x, so plus or minus 9, plus 1, and then divide by 2. So this one we can actually have 2. Oh my gosh, I'm off the screen, sorry. -9 plus 1 over 2. So these are our 2 possible answers. 10 over 2, which is 5. Or -8 over 2, which is -4. So number 11, we get the answers of -4 or 5. So anytime I see something squared in parentheses, that's where I usually go. 12, since we don't have a C, I look at that and I want to complete the square. So that's my method of choice. You could use a quadratic formula too. Might work out pretty well. So half it and square it. So that would be -5 squared, so that's 25. So this, I kind of skipped a step there, just hopefully you got there that quickly. Square root, so plus or minus 5. So x can either be 5 plus 5 or minus 5 plus 5. So we can either get 10 or 0. So if you use the quadratic, you have an A and a B, you just don't have a C. A C would be 0. So it still works, and you still should get the same two answers. Alright, 13, since it's a little bit more complex, and I'm not sure if it'll come out pretty, so I don't want to just try to factor it. I'm going to use a quadratic on 13. Alright, so if you remember on the quadratic, A is 3, B is negative 11, and C is negative 20 because I brought it over. So negative B, let me write that down real quick. So that's our quadratic formula. You'll use it a lot. You can remember it pretty easy. Alright, so negative B is 11 plus or minus B squared is 121. Take away 4A C all over 2A. So we have a lot of simplifying to do on this one. So let's do 4 times 3 is 12. 12 times 20. So this is negative 240. So that would be 121 plus 240 because the two negatives cancel. I'm going to keep going. 240 plus 121 is 361 all over 6. And let's see if we can make this prettier. Let's see, is there square root of 361? I'm not sure. So the square root of 361 happens to be 19. That came out nice and pretty for you. So we have two options here. We can do 11 plus 19 over 6 or 11 minus 19 over 6. So this is 30 over 6, which is 5, or negative 8 over 6, which can be reduced down to 4/3. So we have answers of 4/3 or 5. Negative, sorry, or 5. Alright, number 14 says use the quadratic equation. Write a quadratic equation in standard form of the given solution set. Alright, so we can start by making a quadratic that looks like this. We want it to be 4 or 1 when we have our answers. So if this was negative, we would have changed it to a plus. And then we're just going to FOIL. So x squared minus x minus 4x plus 4, and then simplify it. And that is our final. So that is a quadratic equation in standard form. Alright, 15, the area of a rectangular wall in a classroom is 152 square feet. Its length is 5 feet shorter than 3 times its width. Find the length and width of the wall of the classroom. Alright, so first just remember the area is length times width. So in this one we have to define our length and width using x. Since they give us kind of a puzzle, we don't really know what the length or width is, so we use x to represent that unknown. Usually what they say last is what we call x, and then we read our puzzle and it says it's 5 feet shorter than 3 times whatever the width is. So 3 times and 5 feet shorter. So I used the puzzle they gave us in terms of x, and I wrote that. So now we're going to plug it into the formula we have. So 152 is our square, is our area. Our length is 3x minus 5, and our width is x. So we're just going to solve it. Distribute first. I'm going to bring this guy over here so that we can factor it. Since it's some pretty big numbers, I mean, you can use whatever way you want, but I think the quadratic would give us the quickest way to solve it. Alright, so negative b plus or minus b squared minus 4ac all over 2a. Alright, so we're going to simplify it even better. So we have 152 times 3 times 4, and I get, for this, I get negative 1824. Let me do that one more time. 12 times 152. Good. And that would be 25 plus 1824. And that's 1849 all over 6. Alright, let's see. Find the square root of 1849. Which is 43. Oh, sorry, this is gone. Over 6, so we have 5 plus 43 over 6, or 5 minus 43 over 6. Running into our other work. So this is 48 over 6, so that is 8. And this is going to be negative. We do not have negative sides, so this is going to be our only answer. Now, when I did this, I found x. So x is our width. So when I plug my x into the second equation, I get 19. So we have 5 feet for our width and 19 feet for our length. And again, you could have used any formula. You could have just factored it the old-fashioned way, but the numbers are quite large, so it probably would have taken a while to find the factors. Quadratic is really nice about that. I mean, you've got a little bit larger stuff to deal with, but it's doable. If you had a calculator, like I don't. Alright, number 16, find both x and y intercepts of the quadratic function. Alright, so if you remember, to find the x intercept, you can just factor it. So number 16, if I factor this, this is a perfect square. I can get x is going to be 2 or x is going to be negative 2. So my x-intercepts are 2, 0 and negative 2, 0. So I have 2. The y-intercept, you can just set your, so this, let me write this. This is my x-intercept. My y-intercept, I can set my x to 0. So if I make this 0, this whole thing will equal negative 4. So my y-intercept is 4. I'm sorry, negative 4. I just said it. So same thing here. Find our x-intercept by factoring. We need 6 and 3, 9 and 2. What am I missing? I'm missing something easy. Well, since it doesn't come out pretty, then I'm going to use the quadratic formula to factor it. So our A is 1, our B is 10, our C is 18. So we got negative 10 plus or minus b squared minus 4ac all over 2a. So since it didn't come out pretty, that's why I'm going here, because there's nothing that can factor easily, so I know that it's going to probably involve some kind of imaginary number or some radical. Alright, so let's simplify this. So 18 times 4 is 72. 100, take away 72. Is 28. All over 2. So it doesn't have an imaginary number involved, but it does have a radical. So negative 10 plus or minus, we can kind of make this prettier, breaking it down a little bit further. 2 radical 7 all over 2, and then we can simplify this. This is negative 5 plus or minus, canceled. Alright, so number 17, my x-intercepts are negative 5 plus or minus radical 7, 0. So that's 2 of them. And then my y-intercepts, we can just set it to 0. Set my x's to 0. So 0 plus 0 is 18. So that one came out kind of nice. Alright, so number 18, we have a graph, and they want you to pick the equation that fits the graph. So don't forget, we have a formula that can help us with this, and it is in the form of this, where your H and your K are your vertex. So that'll help great. That'll help us know, where our vertex is. So let me write this down here. So H and K is our vertex. Alright, so the first thing you know is, well, all these are. Since it's pointed up, then it has to be positive, which in this case, all of these are positive. Alright, so then we also see that our vertex looks like it's about 2, negative 2. 2, negative 2 is our vertex. So we need to find the formula or the equation that fits that. So our H is 2 and our K is negative 2. So since this is positive here, then we know that it's got to be a negative 2 at the end. So that eliminates these two. So we're down to B and D. Now our vertex is 2. So it should say x minus 2 to be able to fit. If our vertex was negative 2, then that 2 negatives would make this a plus. So that leaves just this guy here. Alright, 19, sketch the graph of the quadratic function, give the vertex an axis of symmetry. Alright, so remember you can find the vertex, and this is the x-coordinate of the vertex by using that. And then to find the y, you just plug the y, what you get into, find for the x, plug it into the original formula. Alright, so our A is 1, our B is, hold on just a sec. And our B is 0, so be careful there, because it has to be in the form of ax plus x plus your constant. So this is our constant. We don't have a B term. So you put minus 0 over 2 times 1, we get 0. So our vertex for our x is at 0. But to find our y coordinate, we're going to plug it back into our original equation. So if this is 0, then our y would be 9. So we're kind of going to draw this here. So 0, 9, somewhere around here. And we know it points upward. And it's going to look like so. So they're not asking for exacts. It looks similar to that. Your axis of symmetry is where it goes down the middle, which is always where your x coordinate is. So our axis of symmetry is 0. And then you just tell what your x coordinate is there. Alright, 20. Sketch the graph. Identify the vertex intercepts in the equation for the axis of symmetry. Use the graph to identify the function's range. Alright, so the vertex, make sure it's in the right form before we start this. So if we use negative b over 2a, this will give us our x coordinate. So that would be negative 3 over 2. So our vertex, we know the x part of it is this. Then we're going to plug it into our formula where we see x's to find our y coordinate. So 2 plus negative 9 2s plus 9 over 4. So we have some fractions to deal with. So 4 minus 9, 18 over 4 plus 9 over 4. 8 take away 18 is negative 10 plus 9 is negative 1/4. So our y coordinate is negative 1/4. To find our x-intercept, you're just going to factor our problem. So if we factor that, we might be able to factor this one pretty easy. So this is x and x, and we have 2 and 1 and plus and plus. So our x can be negative 2, our x can be negative 1. So negative 2, 0, and negative 1, 0. Our y-intercept is setting our equation, our x values to 0. So 0 squared is 0. 3 times x is 0, or 3 times 0 is 0. So we're just left with 2. So we have 0 and 2. Our axis of symmetry is where our vertex is on our x, so it's right here. So if we were to draw this guy, so negative 3 halves, that's a little over 1, and down 1/4, so we're assuming it's somewhere in here. And then we're going to hit the x at negative 2 and at negative 1, so it's kind of tight. And then we're going to hit it at the 2. So here, so it's kind of looks like this. There's no point on it, but because it's so close together, it appears that way. But it looks similar to that. And then if you remember our range, your range is just what your y values are. Well, our lowest here was negative 1/4, and it actually touched that. And then it goes on forever and ever, so it goes to infinity. So it goes out this direction, which is infinity. So 21, determine whether the given quadratic function has a minimum value or maximum, then find the minimum or maximum value, determine where it occurs. Alright, so remember, if it's in this form, as long as this first guy is positive, your graph is going to look like that. So that means we have a minimum, because that's as low as it can be. And then we want to find our vertex. So if you minus b over 2a, this will give you your x. So that's 2 over 2, which is 1. So our x is 1, and then we plug it back in. So 1 squared is 1. 1, take away 2, take away 3. So it's negative 1. So we got negative 4. So that's our vertex. So our minimum is going to be at 1, negative 4. Alright, 22. The profit that the vendor makes per day by selling X pretzels is given by the function. Find the number of pretzels that may be sold to maximize profit. So we want to know pretty much what our vertex is. So we'll use our formula to be able to help us out. So minus b over 2a. So that's 1.4 over 2 times negative 0.002. So 2 times 0.002. It's 1.4. The negatives will cancel out. And 1.4 divided by 0.004. I get 350 pretzels. So that is our answer for 22. So the reason we didn't have to go any further is because if we have a graph here, the y is our money, and our x is how many pretzels, because they told us that. So we're trying to figure out at the point when this gets the highest, that we don't care what our y is, we just want to know how many pretzels we need to get to that point. So that's why you only had to find your x value. Alright, 23 says solve the equation by making appropriate substitutions. So we're going to do the u substitution on 23 and 24 and 25. Alright, so I'm going to let our u equal x squared. And I'm just going to plug it back into our original formula. So if u is x squared, then x to the 4th would be x squared. So then we factor this. 144. 2 and 72. It's not 12 and 12. And 48. 4 and 36. So I found it. So it's 36 and 4. Oops, let's not use x. And we need it to be negative and positive, so u can either be 36 or 4. And then we're going to plug it back into our original to find what our x should be. So 36 equals x squared, or 4 equals x squared. Square root. Square root. So x can be plus or minus 6, or x can be plus or minus 2. So our answer on this one is C. Alright, 24. Our u is going to be x plus 3. Whatever your second term is usually what your u is. So if we plug back u everywhere we see x plus 3, so we have u squared plus 2u minus 24 equals 0. And then I'm going to factor this. And let's see, we can do 6 and 4 as long as this is a positive 6 and that's a minus. So u can equal negative 6 or 4. Then I'm going to plug it back in here. So this is x, I don't know why I just did that, is negative 9 or 1. So we look at 24 and our answer is B. And last but not least, we'll let our u equal square root of x. Well, when you do the square root of x times the square root of x, you just get x. I'm sorry, I shouldn't have said. The square root of x times the square root of x is x. So if we do u squared, which is basically what I just said, that'll give us x. 9u plus 18 equals 0. Factor u, 6, and 3. So u can be 3 or u can be 6. Plug it back in. Square this, so x can be 9. And we have 6 equals square root of x, square. So x can be 9 or 36. Let me know if you have any questions.